Good morning, ladies and gentlemen, and welcome to the live demonstration area. We are very pleased to welcome back to the demonstration area once again Magnum Venus Products. MVP is a global manufacturer of fluid movement and production solutions for industrial applications in composites and adhesive markets. Charles Tur is a specialist in resin transfer molding and infusion technology from MVP, and he will be joined by Johannes Stolch, a processing technology expert from Teijin. And Charles is now going to show us how to implement MVP secure vacuum bag seal to reduce consumable cost and waste, decrease time and labor requirements, and improve part quality and consistency. Charles and Johannes, the demonstration floor is yours.
Thank you very much. Welcome, everybody. We are going to run the presentation in two parts. One part is this morning, and the second part is this afternoon. We want to talk about different things. Here, we are going to talk about a system to seal a bag and to inject the part, which we call Secure Vacuum Bag Seal, SVP. The point is today we find hard to get workers. And the worker we get, they're not necessarily specialized. So what we want is to avoid any trouble in production. So we have to secure more and more the process. This is one of the examples of what we do. We really focus on security. When we do an infusion, as you have seen here, which is fantastic, they are sealing the bag with tacky tape, which is fine, working well. You just have to be precise on what you do to be sure that there is no air leak. You have different kind of tacky tape, different kind of bag. It's working well. Here on that pictures, you can see on the left the way that we infuse a swimming pool, I will say 15 years ago, and the way that we infuse the same swimming pool side today. So for that, you can see that there is an injection machine connected to reusable silicone resin channel, and there is no tacky tape to seal the bag on the bottom. Silicone resin channel with plastic bag to infuse the part with security. As you can see, there is nobody around during the injection. We have a machine, we inject the part. When the resin stops, the operator just have to flush the machine. It's easy and simple. The solution we provide today is the one you can see. So we have the same plastic bag, which is the only consumable, a reusable resin channel in the middle, and then the SVB seal around to seal the bag. It's a two-part seal. On the mold, we have a groove that you can see here. There is a groove all around the mold. That groove is helping to use the SVB seal, and you will see this afternoon is helping also to use the silicone membrane. So, and then there is a second part of the seal that we can clip on each other. Simple to use. That seal are completely reusable because they will never be in contact with the resin. So we have the groove. We load the fiberglass. Then we have the resin stopper because we don't want to have any resin coming into the vacuum pump. We have a resin vacuum channel if required, according to the part. And then we load the plastic bag on the top of that. At this time, what is interesting is that you don't care anymore about folders. It's not your problem anymore. You just push the plastic into the groove using the first part of the seal. Doesn't matter the quantity of the folders you have. At this time, you are able to apply the vacuum. It's good enough to pull the vacuum. You have good vacuum, but you know that you still have air leak. Where that air leak is coming from the edge of the plastic, where are the folders. You don't want any air leak. So to control the system, we trim out the plastic around. And at this time, we come to load the second part of the seal. We clip the wing seal on the first part of the seal. And at this time, we apply a vacuum on the second vacuum channel that we have along the groove on the mold flange. And then when we pull the vacuum where the air is coming from on the edge, you guarantee zero air leak, just because it's impossible. You pull the vacuum where the air is coming, so there is no vacuum. Then you can produce. If you have a large part and you say, oh, it's large, I'm afraid that my seal will go out, you have the possibility to inflate the seal. We calculate that there is a a wall inside. So when you inflate the seal, you compress the plastic bag on the vertical side of the groove. That's an option. It's not necessary. I don't do it here. So when you want to connect the seal, we have a special connector for that to inflate and to connect the seal. For that, to install the seal, you trim the seal at the right side. Then you use a silicone glue. You put 2 little tubes inside the hole, and you just bonding. You leave it cure for the night, and it's done. That's it. And for the second part on the top of that, you put edge to edge on place with the silicone glue, and no more. And you are ready to inject the part. So how we do it? You have the plastic bag. As I explained, you push the plastic bag into the groove. You don't care about the folders. Then you apply the vacuum. It's good because at this time you want to push the glass properly on the corner, so it's good that you don't have the full vacuum. Then you use electrical scissors. You trim out the excess of plastic along the SVB seal, and then you load the second part of the seal. For that, we have a groove below, and along the groove, we have a second vacuum channel, and we have some little holes along to pull the vacuum. The hole that you see here is 3 millimeters hole along. So then we load the second part of the seal, and then we inject the part. So it's working like that. The second part, we pull the vacuum, and it's done. So here, I wanted to check the process. I inject the part with a standard injection mat. We inject the part in 5 minutes, but the resin shell time is 1 hour. During 1 hour, if there is any little air leak, you will have air on the full surface of the part. And you can see after 1 hour gel time, so we demoulded the part after 2 hours, there is nothing. You have the possibility, when you use the system, to use what we call an ejection valve. And then see that part when we demold. There is no air bubble, no microporosity, nothing. And there is no gel coat on the part. It's just a standard injection mat. So let me show you how it's working. We have the plastic bag here that we trim. And when we trim the plastic bag, we leave it a little bit longer. And as I explained, you just put it pushing into the groove with the first part of the seal. You don't care about the folders. Folders is not an issue anymore. At this time, when you have done that, you are able to pull the vacuum on the part. So this is what I'm going to do. I open the vacuum. So now I'm pulling the vacuum. The vacuum is coming here and on the other side. And I apply the vacuum here. So you will see that we have enough vacuum. So it takes time to pull the vacuum. It will come. Now, what I'm doing, I'm trimming the excess of plastic. So I take electrical scissors. Voilà, that's it. Now you can see that on the part, we have already a good vacuum, a strong vacuum. But we still have leak on the edge of the plastic. So I want to guarantee there is no... So what I have to do now, I have to clip the lip seal into the first one. The point is silicone. Silicone is rubbering. And to avoid that, we just use a little bit of water and soap to help the silicone to slide on each other. We just do it like that. Then, in this time, we're able easily to clip the seal into that, into the first one, just like that. We put it well into the corner. Then, if we need, we have the possibility to use a roll. And that roll just helps to push around the seal properly into the position. And now what we do, we apply the vacuum through the hole. And when we apply the vacuum through the hole, we seal it. So now we are under vacuum, and we guarantee zero air leak, just because it's impossible. It's so simple like that. So now I can inject my part. That seal will never be in contact with the resin, because it's on the top of the plastic. So the day you want to change it, you go to another mold, you trim it or you extend it, you do everything you want. It's so easy like that. So you buy it forever. So let me show you some details. Here is the resin channel. So one thing is the system. The second thing is to introduce the resin. To introduce the resin, we want to be able to use only one injection port. Doesn't matter the size of the part. So for that, we use a reusable silicone channel. The point is when you use the spiral tube, by the side of the spiral tube, you are limited for the resin flow distance. Here, with the collapsible resin channel, we are not. You have one injection port, and the resin can flow 15 meters both sides. One injection port. But you can also do sequential. How we do it? Look at that. One injection port on one side of the channel, 15-meter panel. We just inject the resin step by step, and the resin flow. Then we stop putting the vacuum into the resin channel. The resin channel come back, and we don't see how the resin channel is working. I'm going to show you why. One injection port, 15 meters long. So in production, it's saved because you have only one place to connect the machine. You avoid a lot of possibility of mistake. And by the connection we have, we do not need any tacky tape on the injection port. So the collapsible channel is working like that. You have a mold where you load the fiber. Then you come with the silicone membrane on the top of it. At this time, you apply the vacuum to compress the glass. Now you come here with a second vacuum that you connect on the top of the collapsible channel, and you pull your vacuum. Then the channel collapses. At this time, you have a free channel to introduce the resin, and the resin will flow first into the channel and then into the part. Just before you finish to inject the part, where you have injected the right quantity of the resin, and that is done by the injection machine you have here, because on the injection machine, we have a stroke counter that will predetermine the quantity of the resin we want to inject. And it will stop. Doesn't matter where the resin is. And the good point is, we stop putting the vacuum on the resin channel before the resin finish to impregnate the part. Why? Because the quantity of the resin you have on the resin channel will finish to fill the part. That's all. And when you demold the part, you cannot tell how we inject the part. So for that, we need an injection port. My injection port is somewhere here. Was here yesterday. OK. No problem. I missed that. Yes, here. So we have a mold. And on that mold is a 3D printed mold. We pour the silicone, and we demold, and we have the injection port that I'm going to show you now. So you 3D print the mold, and you have the injection port. That injection port has a lips. That lips help to introduce the resin into the resin channel. So what it means? You have a resin channel. You pull the vacuum on one side. That will collapse the resin channel. That will open the lips of the injection port, and the resin will flow. Now, if you want to send the resin on both directions, you pull the vacuum on both directions. But if you can do that on the straight line, you can do that on cross. You can make sequential injection by using one injection port. So how it's working, you connect the valve, you pull the vacuum on the resin channel on both sides, then you introduce the resin. The resin will flow. By the machine, the resin will stop when the right quantity is injected. And when you stop pulling the vacuum, what happens? Then we fill the rest of the part. Now you can do the same in sequential. So you have that resin line system. What you want now is to introduce the resin only in the center. For that, it's easy. You just apply the vacuum on the center line of the resin channel, and then the resin will go only where the lips is open. So the resin will flow. When the resin arrives on the second line, you stop putting the vacuum in the center, you apply the vacuum on the second line, and then you continue to infuse the part. You can do anything you want with a single injection port. We have inject part more than 36 square meters with a single injection port with that system. But the good point is you can go far away. So this is how it's working. We pull the vacuum, the resin go only in the middle. You stop pulling the vacuum in the middle, and you pull the vacuum on both sides, and the resin will go on both sides. It's all silicone. So this is what we do here on the blade. It's a 15-meter blade. So we load the glass, core material. We load the silicone channel in the middle. So imagine we have 3 lines. Imagine the time we need to load the spiral tube, taking care of the distance and so on. Here, you just unroll the roll of resin channel on 15 meters. In 2 minutes, your resin channel network is done. Then you close the bag, and you just inject the part. So you connect that to the machine, and you know what is nice on this picture? We inject a 15-meter blade. I agree, it's a small blade, but there is nobody around. The injection machine do the job. That's why we develop that at MVP. We produce machine, we sell equipment. We work also on the closed mold process to help customer, but that works because we have an injection machine who make the job, and that machine will stop precisely when we want. It means each part will have the same quantity of resin and the same quality. That's the idea. And the people, instead to stay on the front of the infusion, they work on the next part. And they don't have to be specialized. If they use all this material, they just push the button of the machine and they make the job. So that's why we work with a secure vacuum bag seal. Like that, we avoid mistake if they are not good with tacky tape. And then we have the collapsible resin channel. And look at that. When we remove the resin channel, you cannot tell how we have injected the part. There is no resin waste. There is no excess of resin. There is no print-through. That's the goal. And look at the part. So we have a distributor all around the world, and one in Netherlands is working well with a customer for a project of roofing. They make big roofing panel. So the quantity was not good enough to make a full silicone bag. So that's why they decide to put resin channel network with plastic bag. And look what they have done. That's very nice, all connected to the machine. So the part we show today and we are going to inject this afternoon with the silicone bag, which is a very special silicone bag that we will introduce to you. The project is to be able to produce a carbon part. The carbon we are going to use here is from Teijin. So we have 2 kinds of process. We can use on the same mold either the SVB Seal with the silicone resin channel or the silicone membrane as we will use this afternoon. So we have made the resin channel. We calculate everything. We put the material of Aerovac, which is the net. We use the Aerofix to fix the glass properly. We have the layup of carbon. And I will ask my colleague, Johannes, to talk about the carbon that we have here. Please, Johannes.
Perfect. Can you turn on? Yeah. Hello, my name is Johannes Stolz. I work for Teijin Carbon, manufacturer of carbon fiber and carbon fiber textile products as NCF, non-crimp fabrics. The special thing with carbon fiber and carbon fiber manufacturing is that you produce the part and the material at the same time, and that the process and the material have to fit together. And this is what Teijin and MVP do in our collaboration. We adapt the material to fit to the MVP process and to the MVP equipment. And the other way around, we adapt the equipment and the process to fit to the material. This is where we produce special materials for the requirements of each application and each process. So Teijin non-crimp fabrics are one example. Low crimp or non-crimp fabrics, high mechanical performance. And here you get the material depending on the geometry on the process. So we change the infusion behavior, the permeability of the material. We change the drapability of the material depending as the process required. And this is what you see here. So.
Okay. Thank you very much, Johannes. So what we try to achieve here is to be able to produce a carbon part with a high mechanical properties on the very simple way. So instead to use pre-preg, instead to use press, just to use fridge and so on, we just load it, and by the system we're able to make a nice part. You will see that this afternoon. So here we use a vinyl ester resin, but it works also very well with epoxy resin, heated with low viscosity. We get a fantastic result. All the material we have used here are from Aerovac. So we have, of course, the vacuum bag, the Infuply, which is the net. We have VMS band and the spray adhesive, which is very good because it disappears completely. So let me show you how we have injected that part. So we load the seal. As I explained, we don't care about folders. We pull the vacuum first in the middle. Then we trim out the plastic. We load the second part of the SVB seal. We apply the vacuum. We connect the machine. And then, after everything under vacuum, we are ready to inject the part. So this is what we do here on the photo. For that, we have a special connectors. That connectors here guarantee zero leak and do not require any tacky tape. So we connect it. That's the system. Again, we talk about security. We are going to inject the part. We can use a valve or not, doesn't matter. But we use a vacuum valve, which is very important. So when we connect that, we connect everything from the machine. When we send the air signal to start the injection, we open the valve, and at the same time, the vacuum valve will pull the vacuum into the resin channel. We inject the part. When we finish to inject the part, we stop. The machine will stop to send the air signal. The valve will close. And at the same time, the vacuum valve will close. But to close the vacuum valve is not good enough because the channels stay collapsed. You need air coming in, but you don't want to lose your vacuum on your vacuum pump. So that valve do the job. It blocks the vacuum from the vacuum pump, and it let the air passing through to be sure that the resin channel come back on its original position. You guarantee that people in production don't forget to disconnect the resin channel. Again, this is very important, and this is what MVP focus on. So now we're ready to inject the part, and this is how it's working. When you send the resin, because it's a big channel with the pressure of the machine, you send the resin along the resin channel everywhere. And then the resin flow step by step. We inject the part in 5 minutes. Of course, we can go faster, we can go longer. It depends on the distance of the resin flow, the quantity of the carbon we put, and the resin viscosity. And that's it. Now, what we try to achieve here is that when you demold the part, you demold the finished part. Don't need to be trimmed. Why? Because we have loaded all the carbon fiber into the mold precisely. So we avoid the work of trimming the part. That's also an advantage. So then, this is when we demold. We remove after that the resin, the net. And then this is the part we get. And that's the part we have. So the resin we have used today is an epoxy vinyl ester resin from Poland, which is a fantastic resin, which is designed for boat construction with 2 hours gel time. And they modified the gel time for us to have like 15 minutes. That's the resin we'll use this afternoon. And that's the part we get. So again, on that development, we try to reach high mechanical properties using the right carbon and the right combination. We do that with vinyl ester, but most of our development are also with epoxy resin, okay, to get a very good result on a very lower cost than pre-preg. So we focus on safety. That's the most important for us. We understand the problem to find workers all around the world, so we have to answer. That's the answer on MVP. I think is my last slide. Ah, no, I forget. We do organize training all around the world. We do that at customer. Here, for example, we are in Egypt. We do that with our distributor and then customer in our distributor location. Here we are in Mexico. Or we have a training center. We have a training center in France where you can come with your part and making membrane or anything you need. Or we have the same in US, and our next training in US will be the second week of April in Knoxville, Tennessee. We would like to thank Pauline for the resin, Elkem for the silicone. You will see more this afternoon. And Iovac for the material. Our next demo this afternoon, when we will inject the part with the silicone bag, will be at 2:30. Voila. We have 40 seconds now for the question if you want. But feel free to come to us. You can see all these things in detail on our booth, which is all 5U58, that direction. Thank you very much for your attention, and see you later.
Thank you so much, Charles. Ladies and gentlemen, don't hesitate to come over on this side and have a discussion with Charles, or to visit him at his booth, as well as the folks from Tejan. And we are going to be starting in just a little bit less than 5 minutes with our next demonstration from Aerovac Composites 1. Thank you so much for coming, and enjoy your afternoon at the Czech World Show.